Okay, it's 5 after, so might as well get started. I have, of course, too many slides, not enough time. So, um, talking about stood optional TREF, which, as of a couple of weeks ago, made it through LWG. So we're wording complete. It'll be on the like barring disaster on the polls at plenary in Sofia. So, like, done. um, but this took a really long time, and I'll be talking about just how long some of this took. I'm Steve Downey, by the way. I work at Bloomberg. I've been at Bloomberg for a little bit more than 20 years now. Started there in 2003 after bouncing around Wall Street for a number of years. I've been involved in C++ since mid-90s. Been involved in C++ standardization for about 6 or 7 years now. Had a few other smaller things. I've mostly been involved in text, which we'll eventually get in. But this is partly a discussion about optional itself and what it does and what we had to do, and also some of the fun with the standards process itself, and how we're improving things to make it better and easier. So, quick thing, the colophon. This is intended to be a accessible presentation using Reveal.js slideware, an Emacs mode for generating that from org mode, using hyperlegible font from the Braille Foundation, and accessible color themes. So hopefully everyone can read this. So talking about standardizing optionals over references. Optionals were first proposed for C++ in 2005, including optionals over references. We finally added optional T where T is constrained not to be a reference in 2017. And we're on track now for C++ 26 for getting optionals for lvalue references in. Specifically, lvalue references, we talked a little bit about doing this for R-value references, and there were enough disagreements for what the exact semantics would be that I pulled that part of the proposal, because it's like, this is obviously not baked, but it needs more work, but it's also straightforward, extensible. It's like, once we decide what exactly we want, it's like we're not blocked from doing it. So why so long? What were the concerns that made the process take so long? How did we address them? What did we end up with? And what remains to be done? Basically, the core difficulty is that references just aren't values. And types containing a reference don't have value semantics. And this is a problem. References themselves don't really fit comfortably in the C++ type system. It's like if you've put a reference member in one of your types and suddenly everything is bad, like you have to write all of the special member functions yourself and make all these decisions now. There's a reason for that. The core type that does have reference semantics, that it is a value type, is a pointer. This optional over references acts pretty much like a constrained pointer. It's better than a pointer in some ways. Read Barry's excellent why he wants optional over references instead of pointers, his blog on that. It's a better expression of intent than just a pointer. Pointers do way too many things, and the type itself doesn't tell you what the expectations of the use are. The other thing is that this has been a sort of proxy for the larger discussion of what we should be doing for reference semantic types in the standard library. We knew there was a lot of other places we want to do them, but it's like, this is the first place it really came up. And until we had an answer for that, we weren't going to do it in other places. Quick overview of optional tref. It's a non-owning type with reference semantics with one additional value that represents the empty state. That sounds a lot like a pointer. Yes. Although with pointers, the null state is built in. So there are situations where you can't quite distinguish, was this an empty pointer or is this a null pointer deliberately? You can always distinguish this with optional. So, okay, template class T, specialized with optional tref, has a value type. The iterator is implementation defined. We've added range support for optionals fairly recently. It's really straightforward. There was long discussions before we had decided we could make it a range about whether it was a container or not, because saying something that's a container has a lot of other properties associated with it. And particularly early on, we had no other fixed size containers. So we also had to then decide, what if you try and append something to an optional that's engaged, and what does that mean? We hashed that out when we had fixed size arrays now, and for a range, this just acts like a span. It doesn't participate in most of the container things. Yes?
Naive question, why wouldn't value type be tref?
We had a lot of discussion about this. This makes it integrate in a more straightforward way than if you're converting over. It's like you've got existing code and you've got optionals, and your generic code wants this to behave like a tref. Partly it's also, tref's not a value. So that it's like, if you said that's the value type, suddenly lots of things that you'd want to do with the value type of the optional would break, because you couldn't then create an empty one to assign later or things. It's a generic problem.
And then a follow-up.
Yeah.
I'm not familiar with sort of most all the other sort of STL library structures and data structures that have value type. Those are all values also?
Yep.
So everything is already values in itself.
Everything's already values with these. It's like, and there's generic code that wants to take that value type and do something with it. So it's like, if you say the value type is a reference, you can't just say, give me an instance of X : value type, and your code breaks. Few constructors, the basic simple ones, it's like mostly defaulted. The null op t isn't, but doesn't really do anything. It just constructs an empty one the same way that the default constructor does. It specializes it. There are a lot of other constructors. There are way too many constructors. There are way too many constructors in optional itself. This was 80% of the difficulty in getting the whole thing to work, because overload sets are hard for our brains to work with. We tend to think of it as like a decision tree. Like, the compiler doesn't. It looks at the set and tries to pick the best match. So we had to spend a lot of time working on the constraints so you got the one you wanted, not one nearby that the compiler decided was better. it's like simple destructor. It's like assignment is really straightforward for optional tref because underneath it's got a pointer. So all optional T has a lot more assignment operators. It has specializations for it's like converting assignment operators. It's like both converting from a different optional or a different convertible U that converts to the T. We could sidestep that. We put it back into the constructors. So, yeah.
So it's interesting to take a null op as an assignment if it's a reference.
Yeah, that'll empty it.
Okay, so it's more of a way to clear things out.
That just
empty.
clears.
Okay.
Yeah, it's like I want to reset it, and you could use the reset method, but it's like there's a parallel one on the base type. Like if we were starting from scratch, we wouldn't have done this way, but we're trying to make this work as much as we can, like the base optional types. So that it's like if you want to say, I now want an optional, but I want reference semantics, your generic code mostly works. References are always have new edge cases for your code, but and a swap, which does what swap should do. Iterators, so you can, the begin and end are just like, begin is the thing in there if it's in there. Otherwise, begins is equal to end, and ends just a sentinel. This, I wouldn't recommend highly using this, but it shows up in a range of 0 or 1 shows up in a lot of algorithm code, where it's like, you're desugaring some algorithm and it's like, oh, and then you convert this to a range of 0 or 1 if it exists, and then you do other stuff to it. So having this just makes a lot of machinery easier. It essentially works out as a different way of writing filter. Rosan?
Yeah, you said that and is sentinel, but you show iterator. Am I missing something?
The iterate, it's not actually a sentinel in this case. In this case, it works like a sentinel, though. That's it. They are the same type in this case because it's like that was easy, straightforward to do. The pile of observers for it, including an operator arrow. Optional is the dumbest smart pointer in the standard library. We don't usually think of it that way, but if you try and classify, like write a concept for something, is this a pointer or smart pointer? Optional falls right into that. Again, maybe that's not the best design, but that's what we did. That's what it seemed reasonable at the time. It's like the monadic operations. We're able to get all of the base monadic operations to work over references. They all do the right things. We're actually able to constrain things even a little bit better than we were for the base optional because we know a little bit more about the underlying types in this case. And it's like, and here's the reset. That's the equivalent of the assigning the null op t. It's like, this isn't really the surprising part. This is just like, oh yeah, if I was setting out to do it, I would have most of these things, except maybe some of the conversion operators and the constructors. Again, far too large a set. It's optional is kind of promiscuous in like it tries to help you doing all the conversions that it could possibly do without you having to write them explicitly. And that can be a problem in practice because it will do something for you even if that's not really what you meant. and now you have to, it's like somehow figure out how to exclude that. And some exposition only details. It's like, although really this is the implementation. We're just not, like in the standard it says this, in my implementation, this code is there. And that convert ref init val is just used in the constructors where it's like, okay, you've given me stuff, I need to have something that I can take its address of and put into that pointer, and that code does it. Okay, here are all the papers that went into before 2988 started in 2023. There are a lot of them. And going back to 2005, what's particularly interesting is the 2005 paper essentially proposes the semantics that it proposes having them for references with basically the semantics that we've agreed to here. That took a long time to convince everyone that that was the right answer, but go into that in a bit. The other is so we almost got them in for 2014. It's like at the last minute, we found it's like a couple of implementation problems revolving around it's like const expert and some undefined behavior with some of the implementation techniques that were used. Those got fixed in the language itself, so we were like able to work through that. But that's how they ended up in the library TS. But since then, Library Evolution Working Group has come to the conclusion that the best way of spelling library TS is GitHub repository. But if you're hoping that your implementer has them in the experimental namespace, signaling that they might change, no one ends up using them in production code. So they might as well be off in their own namespace entirely, unless it's something that also involves some compiler magic, where it's like this is the library interface to this compiler feature, and they've got to go together. So you couldn't implement them yourselves anyway, but that's really a niche case. For different reasons, language evolution isn't entirely thrilled with TSs either, so don't necessarily expect a lot of TSs in the future. Basically, it's got to be something that we implementers won't implement unless there's such huge agreement on what the semantics are going to be, and yet no one else is going to implement it either. And for example, this was not the case for reflection. Like we got reflection implementations in experimental compilers without a TS. And then the feedback cycle was much better because it's like, oh, we didn't burn all the time and effort into getting the standardese right in a TS. And now we're stuck with it because changing that is hard. We can just say, oh, yeah, that doesn't work. Let's change it. And then write the standardese based on an actual implementation. The other two papers, it's like 2018, Jean Menendez proposal for essentially what this is ended up proposing, which reignited the debate about assignment, and then his paper explaining why we never see in the wild the assignment choice we didn't make. Talk about that more in a second. So yeah, the problems. Sign or rebind. This is the big one. So I've got two cats, Finn and Loki. They may or may not be around. So I've got optional cat reference, maybe cat 1, Unbound, and maybe cat 2, Finn. what happens when I assign Finn to maybe cat 1 or Loki to maybe cat 2? Does Finn turn into Loki? It's like, do the first and second assignment behave differently? It's like, because it's like, first one's unbound. Maybe we bind in the first case, but then assign through in the second. It's like, that turns out to be a terrible case, and that was John Heath's last paper did all the research. It turns out to be a terrible bug farm if your optional references behave differently depending on the state, because we can't reason about that correctly, and you get bizarre bugs out of it. And then people realize that and abandon that approach. So you don't see that semantic in published and well-used optional implementations. That research, though, took a while. It's like a very important paper doing that research, particularly because from a language theory point of view, it's very tempting to have your optional tref behave like it had a tref inside it. That turns out to be a mistake. But it's tempting. It turns out to be a mistake for the reasons I was saying earlier. You almost never actually want to put a tref in your class type, in your objects.
So actually, that statement there too. Is it a case you're sort of saying optional tref does not behave like tref on assignment?
No,
so it's like one of those key things. Like think about it as like
the way I think about it is like that is that cat ref. That's a request for reference semantics, not I want a reference in this object. This makes this somewhat non-generic. This isn't something you could express in a language that had stricter rules about generic types. Like a lot of languages, it's like you get one definition for your generic type. You can't specialize it into something else entirely. C++ lets you do that, so we can do that here.
But doesn't it mean that perhaps optional itself of the RFT should be like immutable? So if we just assign it once and then we eliminate a huge bunch of issues, so assign one, that's pretty much it.
I'll get to that in a second. It's like we did something slightly differently. Basically, what you'd want is, I think, an optional const tref, which will have deep const. It's like this is. I'll get to that in a second. It's
a const optional.
And another thing, like for people who need those semantics, they can create optional of that reference wrapper.
Yeah.
So
it's like. And unfortunately, reference wrapper has some non-great parts to it because it was originally invented as part of the bind domain-specific language. It wasn't intended really as a first-order component for users.
So when I hear we have a template that works in a sort of slightly non-generic way that you can express in these sort of stricter languages,
vector
my mind
bool
immediately goes to vector bool.
Yep.
So
it's like
yes.
it's like we're
Great. Thanks.
It's like references are weird and non-generic. It's like we want to be able to ask for reference semantics. We want to be able to use optional fairly generically, whether it's got a reference semantic in it or not. The language doesn't help us here. But yeah, this is the vector bool problem only for an entire value category.
But we did it right this time.
Yeah, it's like, we're going to let you do this anyway. Only it's like this is less broken than vector bool.
I guess
Vector bool has it's like not only a weird specialization, it's not a very good one either.
what were the like standards discussions like about? Obviously, this came up, and you made the decision to go with this anyways. Like, what was the? I'm probably like jumping in.
We've now had 15 to 20 years experience with this semantic, and people are happy with it. It's a so like let's standardize some existing practice. But it's like and on the other side, it's like the semantic that people who wanted this, it's like a reasonable proposal might have been to have an optional ref type itself, like that it's like that has reference semantics, except then it doesn't play nice with other things where it's like I have a referencey thing here and I want to make that optional, but these are generic pieces that I'm fitting together, and now you want me to do some template metaprogramming to calculate a different type for this that otherwise has all the same work, and it's like it's unfortunate that the other thing, it's like C++14, they couldn't quite be const expr, and that was recognized even at the time at being really unfortunate, but also a solvable problem. So like, okay, we have to make const expr better, and then we can do this. Placement new had a bunch of issues. The union techniques that you use for it. Placement new still has a bunch of issues, but the union technique works. That is, you can have a union where you have your first member is empty and the default constructs and you're okay. Now you just have to do that. Placement new into an aligned buffer still doesn't work very well, full of undefined behavior, and we're still working out like things like launder, start lifetime as, etc., in order to be able to explain to the compiler the clear meaning of what you're trying to do here. And it's maybe can be made to work. Certainly the aligned storage class doesn't do this for you, and has a whole set of problems. It's like, don't use it. It's an attractive nuisance at this point, unfortunately. So design choices we made. Make optional was a like very useful when it was first invented. It's mostly CTAD replaces it. You hardly ever need to use make optional for optionals today. It's like make optional tref though creates an optional T today, like without this. That is because it's trying to infer the type, and your expression inside there was probably a reference. You didn't want it to come out as an optional reference. So this is doing the right thing in a way that makes some of the evolution less great. Fortunately, it's like, so this still does this. You can't get an optional tref out of make optional. You don't need to though, so don't worry about it. Trivial construction. It's like, okay, we got rid of this trivial now. For the rest of it, we've just insisted that they be no worse than they have to be. Like Boost.Optional, some of the constructors and such aren't trivial for no particularly good reason, and a little bit stuck. I mean, because they'd have to break something to change that. So it's like, okay, while we're here, you have to do it this way because it's a little bit better, and you get a like microscopically better code out of it. It's like, not something you have to worry about as a user. It just works. But it's but we needed an answer. That's why I'm listening through the design choices. Part of the thing with a standard proposal that I've found is like, I'm going to try and keep doing this. write down the design decisions you make, because it'll make the conversation go a lot faster. Now, the value category effect, like when you pull the value out, particularly for R value references, what should it return? We're choosing to model pointers, which are a reference semantic value type. The value category of the optional doesn't affect the value category of the referent. It's like the fact that your optional is an R value doesn't mean that the thing it's referring to is an R value. This has a lot of bugs in the wild right now and a lot of implementations. Yeah, and as I point here, this is an actual bug we found. I'll get to it. That's it. Yeah, shallow versus deep const. Your const optional to a reference doesn't make the thing that's being referred to const. Just like your const pointer isn't a pointer to const. It's like, this can sometimes be surprising, but doing it the other way rules out a lot of valuable techniques. It's like you're over-constraining the programmer who's read the docs and knows what's going on to help someone who's just making a mistake in their head about thinking about things anyway. I'm generally in favor of helping the programmers if it's like a balance of two things. Yes.
So it's sort of similar to a smart pointer.
Yeah.
In that way, which is like, hey, the smart pointer itself is const, but the thing it is pointing to
isn't
specified by whatever it is. I mean, if you made an optional t const ref.
Yep, that'll work just the way you expect it to for this. It's like, and since you can spell it yourself, we don't need to bake it in. Your const optional just means you can't reset the optional or do a few other things with it. You can do stuff to the underlying though. So, this is a place where it's like, do you have to spell things with essentially a cast operator? I would have preferred to. Optional doesn't force you to do that, which leads to a bunch of the ambiguous cases where we had to add tons of constraints to make this work. Optional does too many things on its own. One of its use cases is for specifying the value for an optional parameter. So you can say, I've got an optional int and the default value is 5. And you want that 5 to be put into the optional, and you want people to use your API just with ints. So you want this automatic conversion, and then you can tell usually if they've supplied it or not, or what or you've defaulted it to empty, and now it's like you get the empty case out, and if they supply an int, it's like you get it. It's like, it's nice. That probably should have been a different type. The C++ standard has and also the committee has a strong preference to, we've got something in this space. Let's add this use case to the same thing, rather than having several nice, crisp, distinct things. Newer languages have moved the other direction. So it's like you'll find Rust or Swift have like 4 or 5 different things in a space with different trade-offs, and now you have to read the docs to figure out which one you're supposed to be using. But
I might be dumb here.
Mm-hmm.
If I have auto bill equals optional tref parens Jane, do I not construct an optional tref?
It basically gets all elided. It's like you've surrounded it by an optional tref, but then the pointer just gets copied over.
Okay, I understand.
Yeah, it's like it's cheap and it doesn't need that. Similarly, in the optional case, the compiler is very good at realizing I can collapse this whole thing into just an assignment of the underlying types. It's like there's no loss of efficiency.
But going back to that
Yeah.
example, the mental example, auto Jane, was it?
I said auto bill equals optional tref Jane.
Yeah, and
Yeah.
so at that point, what would the type for bill be in that case? Would it be an optional tref type?
I think
or is that
it'd be
one-
an optional tref type.
Okay.
It's a,
Okay, yeah, right.
it's a,
Yes.
but this is one of the problems with having so many forms of this, where it's like, oh, it might have converted into something else, and at which point the compiler will, if the compiler can't figure it out, it just tells you. Value or, very useful function, doesn't work very well for references. We've left it alone, essentially. It's like all the choices that we could make for what this should return surprised someone. So it's returning the value. That was least risky in terms of getting a reference out can be very surprising if you're expecting a value to come out. Future work, generic nullable functions, we should have a free function that's value or that calculates the common reference type, does all the right magic, makes sure things don't dangle, etc., etc. That'll come soon enough.
Okay, so if I had an optional tref that's pointing to bill, we'll go with
Yeah.
bill, and then I say, give me the value or or Jane.
You'll get a
would
copy
I want
out.
a reference to bill or a reference to Jane? I want the reference, not the value, right? So
Yeah, you're gonna have to write that.
okay, so
Which you can. It's like value or is really a pure convenience function.
got it. So if Bill and Jane were big objects, and I
Yeah.
wasn't expecting I get a copy because I just was like auto reference to either.
Yeah, it's like you'll get an accidental copy. It's like, but it's like in terms of safe choice, getting an accidental copy is better than getting an accidental reference.
This blows up the
Unexpected
listing.
references mean you get spooky action at a distance later. Part of a bug I'll point out in a minute. We support in-place T construction. The only problem is there's no place to put anything. So it's like, have to make sure that whatever we're saying in place is actually something we can get a reference to get the address of that thing that's not going to vanish. Fortunately, we've got new compiler intrinsic traits that are standardized to ask that question.
This is just because optional had it? This is just because optional had it?
Yeah.
Okay.
So it's like if we can support it reasonably, we want to either have the code work and do the right thing, or tell you that you can't do it. So not you categorically can't do it. So so converting assignment has similar problems. We avoid the conversions that produce temporaries. Avoiding confusion with optional uref versus optional T constructors. So if because you can construct an optional T from an optional U if they're compatible in some ways. It's like, and we support that. Other things are like, oh, what if you've got an optional T? And this is like, don't do that, but it works. It's like, we don't want to collapse things for you. We don't want to do that by accident. But this was very much a case where the compiler it was very easy for it to fall into the wrong constructor because it's looking at the whole overload set and says, oh, I found this match over here for the most general converting constructor, not the specific one you wanted. And it's large overload sets, very hard to reason about. You have to get all of them in your head at once and work them out. Not the way you'd normally think about them once someone has worked them out, where it's like, oh, it's going to check this one works, and if that doesn't work, that does, and it'll go there. That's not how the compiler does it. So some of the principles in how we reified the class, we avoid taking references to temporaries. This rules out some safe cases, but rules out a whole lot of dangerous cases. And the safe cases are ones where just put the thing that you want, that temporary, on the stack somewhere. The compiler was going to have to do that for you anyway. You just have to spell it that way yourself. So, we delete the dangling overloads rather than removing via concept, because we don't want them to vanish from the overload set. We want to tell you this was wrong. So it's a static assert rather than a requires clause. It's a assignment. It's equivalent to a pointer copy. So we got rid of a whole pile of the assignment operators from the base template, and all of them are essentially through the single function of just copy the pointer over. Core of this, the tref problem. It's overloaded syntax. References in C++, they're used for parameter passing. They're used for named aliases. It's like when you just put a tref on the stack, there's nothing there. That's just a name that the compiler now uses for things. It's like takes up no space. And also the non-null const pointer in a struct. These three things are not entirely compatible with each other. There's a reason no other language after C++ has something that looks like a reference. They have lots of things with reference semantics, but not this. References aren't data. They're co-data, which is something that got invented in the last 20 years or so in programming language research to talk about things like optional and object-oriented objects and infinite streams that don't have any way of being constructed. And I'll be talking about them later this week, my talk in the morning on Friday, or grab me anytime, because I'm kind of excited about co-data because it gives me a way of giving a name to all these things that had a problem that were hard to describe. So yeah, tref in a generic algebraic type. Basically, it's a request for reference semantics. It's not putting a reference in the thing. It's like, reference semantics are good. We want to be able to say, I want to talk about that thing over there, not to make a copy of it. I want to be able to mutate it, or I just really don't want a copy of that. So look up in a map. I want the thing in the map. I don't want to make a copy of it. I want to always get the latest of it whenever I'm dereferencing it. But with map, there might not be one there. We try and do this with iterators, and it's not entirely satisfying. And it's like, yeah, it's not a request for tref weirdness in your struct. And it's the biggest problem for union-like types, some types, variant. And variant is one of the places where we decided not to deal with the problem until after we got through optional tref. It's like tuples can have references in them. Variants, which ought to be exactly dual, can't. Okay, this and Project Beman, which you may have heard about this morning. Project Beman was invaluable for getting the actual concrete proposal, which is based on actual running code, much better and in better shape, more eyes on it, more visibility, more finding the various corner cases. Project basically kicked off last year at C++ Now. I want to be clear, it's not a requirement for standardization. You do not have to go through the Beman project to get something into the standard library. On the other hand, library evolution is going to ask for your implementation of the exact thing that you're proposing, not the one that's really similar to that you're using at work, because the details matter. It's like someone will ask you to make some change, and we've had a lot of experience that it's like, oh, that turns out to break something in some subtle way that we don't notice because all we're doing is doing this on paper, not to an actual implementation. So like, you show up with a proposal in LAWG, maybe not incubator, where incubator is much more concerned about, is this a good idea? Does this look like something that's implementable? Does this look like something that could go in the standard? LAWG is like, I want to see the implementation. And in the past, we've kind of said, yeah, it looks implementable. We'll take your word for it that you can't show us the exact one because it's got some cruftiness in your company version, or it's got the wrong names or whatever. Now we really want to see an implementation with everything spelled the way that you did, with the overloads that you've said, even the ones that we've added, so that we can run test cases and kick the tires and make sure that didn't actually ask you to break something. I had a pre-existing SMD optional because I'm not smart enough, I know, to write standardies from scratch. That I implement something and then write the standardies that matches what I implemented, which has turned out to be much, much simpler post C++ 2023. It's like so much of the stuff it's like the concepts, instead of being something that you have to implement yourself with SVN techniques or metaprogramming, you just write the concept. It's like it'll get even easier now with contracts that you can just write the contract in C++ syntax with your pre and post conditions. But I used it at Tokyo, the one I had in Tokyo, because David Senkel had a counter proposal to one of mine to add range support to optionals. I added range support to the optional implementation. I ran it against all the test cases for my view of 0 or 1, and everything passed. So I was like, yeah, this works. This solves my problem. I'm not happy that we're putting more stuff in optional, but confirmation that that this worked, even though it's like, yeah, it probably worked. What could go wrong? So, in terms of bringing it to Beman project, the only downside is I'd written the CMake that was running the whole build system about 10 years ago with modern CMake at the time. So it's kind of early modern CMake. And it's like we could do so much better. Also, it turned out I was accidentally relying on some of the stuff for install that has been fixed and it didn't work anymore. And I never noticed because I never install from my CMake projects. I'm either using them directly or actually packaging and using the package. It's like the intermediate step was just something I didn't test. And what do we know about untested code? The other big thing, and this is the big bug that exists in TL optional and Boost optional, and I think in at least, I wouldn't be surprised if it exists everywhere. It's a subtle bug. So I've got my cat fin, create a reference to it. So I've got a maybe cat ref and some other maybe cat. When I assign here, it's like I move the maybe cat ref and assign it to maybe cat, fin gets moved from with Boost optional and TL optional because they treated the value category differently. They're basically a bit of standard use bugs come to, but essentially it's like they're like, oh, you've got an R value reference. The thing inside here must be an R value, so I can move it, right? Not for reference types, because you're stealing something that someone else owns. Yeah, we've now fixed it. But in the standard, we wrote down that for a lot of cases, you have to do deref star move right-hand side. That's it.
So the thinking is basically, since the type here is like lvalue ref to cat, like that should force a copy essentially, even with the stood move there.
Yep.
Okay.
Because like that may not be what you wanted, but better than surprising moves from, because someone else will now see this moved from. And then also lots of times that moved from, like for most of my big dumb objects at work, the moved from state is the same as the copied from state. Like there aren't that many types that actually have working move constructors, because we don't have destructive move in the language. So it's like your copy of 15 ints makes copies of 15 ints.
Can we go back just one slide?
Yep, I hope.
Okay, so if these were both cat refs, optional cat refs, the move would just be basically copying the pointer over.
Yeah, and that'd be fine.
And that'd be
this
fine.
is because this one is an optional cat.
And so this should actually be kind of nonsense, because they're trying to move a pointer into a cat.
Yeah.
And
it's
so
like,
this should just fail, question mark?
it's like, well, it's what we ended up doing is like it'll make a copy.
Okay.
Because it's like there is something reasonable to do, and it's like, but yeah, I'm sympathetic. But yeah, that's it.
But shouldn't be. Okay. Go ahead.
I was going to say, and I'm late, so I'm sorry if you already covered this, but I assume you also can do optional cat ref, so like you can't have.
Oh no, you can't do optional cat ref
you
yet.
Okay.
Only because there were some corner cases where there was disagreement about what it should do, which can be worked out. This isn't a fundamental thing. It was like, no, let's standardize the parts we agree on. Can come back and add another specialization for tref ref.
Okay.
That's it.
Yeah, but maybe a question here once again. But should we technically, like, I totally agree with that point. So, like, should we probably disallow this transformation rule, because technically, optional of cat and cat ref are different types. So and
Optional has a ton of converting constructors.
Yeah,
it's like this goes back to if you were being more explicit about all the conversions and not building them into the assignment and copy constructors, it's like I think we would have been better off, and this would never have come up, because you would have had to spell something here in that assignment, because they're different types. But it helps and does the conversions for you. It's like, because it'll also, it's like, you could assign your cat to an animal, optional animal, and that'll work. It'll slice, but it'll work. Maybe you don't want it to slice, and that's why it would have been nice for it not to do it for you.
I just wanted to make sure I understand the justification. Imagine a world in which we're writing generic code and it's an optional of something, right?
Yeah.
And that optional of something might be an optional of tref. And we want, if you are writing code that's generic over anything that you can put in a stood optional, that if you stood move out of that stood optional, it does something reasonable, doesn't explode.
It doesn't explode, doesn't fail to compile. It's like your code will work. Like, try and avoid this. But
Got it.
Is it worth inventing static analysis checks for this edge case?
Unexpected moves, probably. Yeah, that's it.
Full stop, yes.
Literally, they're assigning a reference to a non-reference stuff, like a reference optional to a non-reference optional.
It's like when writing it. Well, okay, writing it as move is probably the wrong thing to have done here. It's like, but it shows. It's like. There is a new GCC warning about it's like stood moves that you shouldn't have written. We've caught a whole bunch of things in our code base with this.
It occurs to me one way to spell this obviously is like this, but then as a comment, no lints, I meant to do this.
Yeah.
Right.
It's like maybe not helping you so much, but yeah, but basically after a bunch of discussion, we fixed this up. So we deal, because what's hidden here, that star is an operator. There's a literal operator star on these, and they do slightly different things in the T and T-ref case. And like, so you were getting the wrong thing out of this. You were getting, and now it's fixed. In the base case, operator star on an R value of the optional, well, it's holding that. So it's going to return an R value reference, because that makes sense, because this is an expiring optional. It's like, sure, you can move from this, like not for reference semantic types. So it's like the optional star does the right thing. The move here did the wrong thing. Okay, future standard works. Oh, sorry.
Yeah, I just had a question about the operator,
Mm-hmm.
the star operator. I was curious as to why it returned an optional instead of just T.
Oh, probably because I just edited this slide this morning and it's like, got that wrong.
Okay.
If we go back to the beginning, it's like the correct one is there because they're taking that from the actual synopsis. Thank you. I'll fix that. Future standard work. Other things, now that we've got agreement on how things should work, there's other places we should apply this same stuff. Stood expected. It's a little more it's 4 times more complicated because it's got a left and a right. And actually even more complicated because it actually doesn't have a left and a right. It's got an expected and an unexpected. And it's like there's a bunch of work on each of those. Nothing complicated, but it's work. If I'd started this the whole thing a year ago, we probably would have gotten expected over references in 26 too, because it's basically mechanical, but stood variant, more complicated because variant is already scary in terms of its implementation, not its logical behavior, but it's like it's not clear to me that we can take the existing variant and change it. A couple of standard library implementers tell me that I'm wrong about that, and I'm like, good, but but clearly it's like now we know what the semantic of having a reference in a variant should be. It should act like a pointer. It's like not you can never change the variant that's active or anything like that. It's view single, which is the dumbest range. It's a struct with one thing in it. Again, it mostly exists because these things show up in algorithms where it's like, oh, we need to lift this thing up. It's the like in senders we have just where it's like take the value and make it into a sender that sends the value. This is make this thing into a range, not because I want a range, but I want to stick this into a range algorithm. It's like rebindable reference, something I would like to propose now that we know what the semantics we'd like are. This would be something a better version of reference wrapper that does just that, doesn't affect how stood bind works, especially since no one should write new stood bind code. I was very happy when it came out because I got stood bind years before I got working lambdas. But you can implement stood bind mostly in C++03. So I got that before we got C++11 where I had lambdas. But it's like language and library features get out of sync.
So stood optional tref is like a raw pointer without any of the raw pointer stuff we don't like pointer arithmetic.
Yeah, you're clear on
array,
who owns what. It's like this acts like a value. This would provide that semantics so that you could stick a bunch of them into your vector.
Yeah, but so rebindable reference would be similar, but for like a non-nullable pointer.
Yeah.
Got
Yeah, it's like okay, you can reset this. It's like if you assign to it, you'll get there's some open work here. There's not a lot exist. Reference wrapper is in the wild, but reference wrapper is either an implementation detail in some places or a hacky workaround in others. It's like I'd like to make the hacky workaround less hacky. And there's a type that's in many places in Range's code, movable box. Given how often it's used in the standard library, and you're supposed to be able to write your own things that work as a range, not giving people this is a disservice. It just means they have to write it themselves, and why should they?
So is it a magic type?
No, it's not magic at all.
Okay, you just don't have to rewrite it.
Yeah, it's like no one should have to rewrite it. It's like no one should have to rewrite it because they will badly. It's like it'll be sufficient for your exact use case, and then something will change and you won't. Early on, there was it's like this was originally I think copyable box and a couple other names, but the ABI has settled down on this. It's like it's not going to change. I think we might as well let people use it for their own purpose. It's like it's the same purpose that the standard library is for. Is like I want to keep a copy of this and have it behave sensibly. But questions. Remember, a question starts with who, what, when, where, how, why. It's like, oops, oh. Hey, skipped over. Okay. Yeah. Or propositional statement, a statement that has truth value, either true, false, but not both, goes up at the end. That is a propositional statement, but hold that for a moment.
That was a little bit unclear to me. What would be like the probably difference, or I just misunderstood it, between rebindable reference and this movable box? Can you elaborate a little bit on it?
They're probably really close to each other.
So
if they turn out to be the same, that's great. It's like I haven't done the work yet. These are like a laundry list of things that it's like I hope someone works on. I might work on one of them.
Yeah, and if you just decide to merge both of them, like there is single entity, so please take the second name because it's shorter.
Yeah, they might work out to be the same. It's like there is some overlap there. I am now much more leery of like these two things are close. Can we make them one thing? Because they're never then quite as good as either of them separately. And you can't put in rule out the slightly broken case for A because it's like you need it for B. And it's like instead of the compiler saying you've done something clearly wrong, it's like okay, I'll make something work for you. Ruslan, did I see your hand up?
Yep. So 2 questions. Do you envision what use cases do you envision for like variant ref and the expected ref? This is the first.
So okay, expected ref, similar to the map lookup cases. Only there may be it's like more complicated. It's like you may want to describe what went wrong rather than just saying no, I couldn't find one.
Okay. And the second question is like, is variant of reference has variant of reference ever been implemented anywhere? Boost?
I don't think so. I've done some work for it, but not like the full-blown thing because variant's hard. I do have code where I know I want to use it. It's in metaprogramming contexts. Tuple is a useful heterogeneous container. Its reference type should be the variant that has the same parameters as the tuple, and then you could have an iterator that is over the tuple and like get the except you can't because the tuple could have a reference. It's like there are other techniques around it, but it's like if you had iterators for them, it'd be easier to like pass that iterator instead of the index and a reference to the tuple that you have to recompose. It's like the semantics become easier. I'm not saying that's a shoe-in or it's like, but that's why I want it, and we should at least decide we don't want it on real evidence now that we know roughly what it should behave like.
I was working on my multiplication tables when this first got standardized, so I'm not fully familiar with the history.
Mm-hmm.
We said that the very first paper basically had the same semantics. Did that paper deal with the overlaps or the nonsensical overlaps between optional on value types and optional on reference types? Like, so we have like,
not really well.
Okay, excellent. So I guess my question is, have you given any thought to what this would have looked like if we could have done it correctly from the beginning, or is just that nature of C++ references like cause this problem?
It's like
is there a...
some of each?
Okay.
It's like the core language reference type is always going to produce some problems because it's just strange. It's like it turns your otherwise normal algebraic product type into something that isn't, and it's like you put it in a struct and suddenly you don't have a nice struct anymore. It's like that's ground level. It's like we still want reference semantics, so how do you spell that? Well, it's like spelling things as a tref rather than a t star, because T star has way too many semantics. It's like, and then everyone's going to have a question about who owns this? Do I delete it? Can I try and delete it? Well, I want to delete it. That's a good thing, right? It's like, the other thing was the being really helpful with all the conversion operators that are built into optional. I would really suggest don't do that many on anything you're proposing today. Just make someone spell what they intend to, and let the compiler like elide all the stuff that you were going to have it to write that code for. It's like making it easier to automatically and implicitly convert from almost anything just makes it really easy to write a bug that looks like it does what you want, but doesn't really. But it's really hard to review code that isn't on paper.
Was the original motivation for this essentially what you just said, which is like to like force a non-owning pointer type essentially, because like it's like you can't delete this thing, but it mostly works like a pointer.
Yeah, it's like I want a pointer, but I want a pointer that it's clear what the semantics are to you when I give it to you.
Okay.
It's like you should treat this like a value. It's like we could have a type that was just like the rebindable reference thing, which would be the non maybe part of optional. we get the null pointer thing as the extra value in optional. We'd also like to be able to say, this is definitely, it's like a non-owning pointer that has limited things, and that's closer to what the rebindable reference would be. Except you wouldn't have to dereference it either. It's like, because it would act like a value, but it's a value that's over there, and you can have a lot of things that talk to the same value.
Yeah, it's interesting because I was working with someone who was new to C++. They tried to write a type, like they basically tried to declare an optional of like some reference type or something. And at the time I was just like, I don't even know what that would do. Like maybe that should work. Like it's cool to see.
Oh yeah, no, that's like, and Boost does.
I found that out at the time.
And so does TL optional, the Cybrand's implementation, which he wrote mostly to do the monadic stuff, but it's a.
Just in light of this question, wouldn't it be like probably better in terms of safety by other criteria to say work more on those rebindable reference or basically fixed reference wrappers rather than on the same things for expected or variant or similar stuff? Because I mean, I totally understand like the reference semantic, we will lose it here, but at the same time we can create, more safe standard library in a sense, of course.
Yeah, that's what I was thinking about. That essentially it's like this would be a way of putting that reference semantics into things that didn't, in a safe-ish way, that hadn't had specific overloads for it. It's like the composition extensionality rather than.
Yeah, and at the same time, we kind of extend the notion of view, right? Because we have now string view, views in ranges, we have span and some other stuff. Why not having like sort of generic view? Okay, that would be another kind of worms with all view issues because of the ownership and lifetime, but still.
Yeah, that's it. Okay, we're a few minutes over. Sorry, I think it's like. Are we we're a few? No, we aren't. Okay. I'm sorry. Good. It's like I had 15 more minutes. I rushed through. That's it. Okay.
So we were. This is almost. I feel like this is like almost like the pathological case for standardization. So I think it's a good opportunity to reflect on some standardization process.
Oh yeah. Why there's this long?
Yeah. So my understanding somewhat is that we said, okay, we definitely want optional T, and we'll figure out optional T-ref later.
Mm-hmm.
But that has caused its own collection of problems. And
yes.
But this is the way standardization works. We say, wouldn't it be better if we got something on the bus this round, it'll be easier to extend later?
Yeah.
Is this sort of like the counter case for that? That once you put something on the bus?
Yeah, it's like that you've locked in a whole lot of choices that you now can't reconsider. It's like, and you might want to. So yeah, it's like if it hadn't been really fundamental, that in terms of like this does. Oh gosh, that's what I forgot to do. Plug in my laptop. It made it through though. Yeah, the big thing was for that. Read. Yeah, the fact that it's like you rule out a bunch of cases. It's like by shipping something early. I think this was a different case because it really was a policy choice that we didn't know enough how to make. Plus the fact that it's like arguments about we're getting a handle on generic programming and having two different things under the same name is not very generic. And I think it really comes down to, it's like ref itself does too many different things. It's like it doesn't have one semantic. It has at least three. Two of which are really useful. It's like, but could have been spelled differently. Like being able to say, I want to pass this parameter by reference is just incredibly useful, even if you couldn't say that for anything else in the language. It's like, and then second, like, I want a more convenient name for this that doesn't cost anything. Great feature. It's like in code review. Like this expression, it's like this sub part of this object. It's like, I'm calling it this. And then you use that name, and the compiler just, it's like knows that this all works, tracks it for you, and that's all good. But then, and you can put this in a struct. It's like, maybe we shouldn't have done that. But but we didn't have in Downey in 1980, whatever it was. It's like, we didn't have all of these library tools and language tools of like, how could we spell this type? It's like, and introduce something that had these semantics and do that. C++ was almost a simpler language at the time.
I can see the argument though, like, I'll say I like optional a lot. I use it, but yeah. I'm like, would we be better off not having optional reference? Like, is there a case you're like to make where you do all this work and you're like, maybe we don't need this?
So you need something like it, and it's like, I think the frequency of its use in Boost code, or people using it from the Boost library, indicates that it's useful and well received. And it's like, okay, maybe we could have done something differently. But there's a whole bunch of stuff that you can write generically over optionals that just works, even if that optional was over a reference. So, yeah.
But one of the probably regular cases, if you say do some parsing or similar stuff and you want to save some memory and do some pointers on the chunks of data, and then you also need to know whether your operation fails or not.
And maybe a better reference wrapper would help this in some places. I mean, it's like there's an alternate universe where we could have done things differently, and I think it would be equally successful. Okay. I largely took this on I found the fact that variant not supporting references unsatisfying. It's like, well, we did it for tuple. Why aren't we doing it for variants? Shouldn't they work together? Can't I do this all generically? And then was told, well, yeah, but we couldn't figure out what to do for optional. And it's like, well, other people's optionals do this, and it's like, and the answer I heard is like, everyone who's tried this has quit. Oh, this sounds fun.
I'm sorry if you already said this. What standard is this going into? 26, 29?
26.
26.
Okay. It has gone through LWG. It's like they forwarded it, so it'll be on the plenary ballot at Sophia. So it's like one of the last things, and partly that's my fault, but that's I was keeping a close eye on this. There were a bunch of even more important things making their way through LEWG. And the view in scheduling this is like, okay, we've got fundamental agreement now on how this works. We've got to review this, but we are not going to have to spend like hours and hours sorting out, like, is this even the thing that we want? It's like, okay, that's done. It's like, turned out there were a bunch of other edge cases to figure out. It's like, but still not controversial ones. A few where it was like, pick one.
And then one other question. This might be beyond the scope of your talk, but I just kind of realized as we're talking about this, I don't know the answer to it. I'm rather embarrassed. What is like the actual ABI for a reference member? Like it's guaranteed to be the size of a pointer, essentially. Like
I'm not sure. Okay.
Because the struct has to be a definite size.
It's like C++ doesn't guarantee it. The Itanium ABI that everyone does use it says it's a pointer.
Okay. Yeah, because like the struct always has to be the same
It's
size.
like, it's like there's a pointer in there. It's just the language now.
The language doesn't specify that.
But right.
Okay.
So we were saying that very, very early in the talk, we said that we can use stood optional tref allows you to tell the difference between a null pointer that is a null pointer and something that is. So if you have a raw pointer, you don't know if that was assigned to null pointer or if it was just empty. But as a practical matter, in optional tref, the null pointer is the empty.
Yes, yeah,
Okay.
but you know that, and it's never a wild pointer.
Got it.
That's the other big thing. That it's like this is not a random uninitialized bunch of memory. It's like we can cut out a lot of the things that it's especially because there's no way to ask if a pointer is valid. Like so.
There's no way necessarily to ask if a reference is valid either.
The fact that you want to indicate something else has gone
very
desperately wrong. But and yes, there are those bugs. It's like dangling lifetime issues are terrible. But it's like, yeah, we couldn't rule it out. There's nothing keeping these things alive. So if the lifetime of your reference expires, you've got a dangling reference, which is just like the worst thing ever.
And that's why it's the dumbest smart pointer, not the smartest smart pointer.
Yeah.
So if someone wanted to play around and like understand the size of like references inside of Beman optional, is there a way to get that available on Compiler Explorer? If you can just play with it?
I think it's already available.
That was a trick question.
It's like this. The adopted exact specification got merged back into Beman optional, and that's a checkbox that you can put in Compiler Explorer and say, I want Beman optional, and then you can include Beman optional, optional.hpp. It's like, which sounds a little bit verbose. It works better for things like execution, where there are a lot of headers, and you want to be able. It's like the fact that there's only one and some detail headers is like it makes it overkill. But it's easier to have policy like this than.
What is like? Is there like big semantic difference between optional tref versus optional reference wrapper T?
Yeah, unfortunately, it's like they're close. But there are cases where reference wrapper won't decay to its implicitly to its underlying, and you have to call get value on it in order to get the value out, and the ergonomics are terrible. Okay. It's like I have written specializations of optional on reference wrapper that do those for you. It was actually originally part of this proposal, and I said, no, I don't want anyone else. It's like, no one should be using this if we get this right. So it's like we don't need the extra set of overloads and magic. But yeah, reference wrapper is mostly transparent, but not entirely transparent. And when it isn't, it's really inconvenient.
And just like, I'll talk for the youngsters. What is the story with the vector bool? I was like so confused.
It's like, yeah, vector bool, we wrote in the standard that it acts like a bit set of length n. It's like, it doesn't act like a vector of bools. It's packed per standard. The iterators don't quite satisfy being iterators. It's like it's broken in so many ways.
So why isn't no one fixing it?
Because we standardized it.
You can
And two people depend on it somewhere. Why does make still require tabs for the delimiters?
That's not as broken.
Yeah, it's broken. The guy who wrote Make said it's broken. He didn't know how to find end of line with the lexer he was using. But by the time he figured it out, there were like a dozen people using it. So he had an installed base who he couldn't break.
That's actually. I was gonna say I've also helped junior devs debug that issue of like that looks right. It looks like it should work, but if you put Vim over it, it's more than one character, so it's not right. But I was just gonna say with optional, with vector bool, I was thinking it was an optional basically the
No, we
standard
mandated it.
It's actually
instead.
mandated.
Yep,
Oh, okay.
it's like
yeah.
Yep, we're over time now.
Yeah.
Fine. But yeah, no, it's like implementations have to provide this, and it's awful. Thank you.